One of the things that we're hoping to provide some little bit of glimpse of an answer for this morning is there's too much to cover, but looking at it as why should I care about soil health? So that's really one of the key things is why should I care about soil health? And there are a lot of things that are there, and there's a lot that we don't understand that goes on underneath the soil, and you'll hear from the speakers this morning a lot more in depth about that. So with that, there are also handouts and a sign-up sheet in the back of the room. We'd appreciate you signing the sign-up sheet. And if you want those handouts, if we start to run out, we can always get those to you. Or you can also download those off of the Stock Growers website at wysga.org. You go to the Programs and Partners tab, and then under Soil Health, there's all that information. There's a lot of other links. There's also the presentations that will be posted there, but looking at a lot of the presentations without the voice, it's sometimes hard to understand what's on there, and that's why we decided to provide the YouTube links so that it would help, so you could actually listen to those as well. So with that, I'm going to turn it over. Our first speaker is going to be Caitlin Price Younquist. She's a University of Wyoming Extension educator based in Washakie County. She specializes in soil management and works with farmers and ranchers around the state. She is originally from Washington State, where she earned an undergraduate degree in animal science and graduate degrees in soil science. She graduate school was never in her plans, but encouragement from a mentor and an employment as a research assistant changed her mind. After earning her master's degree, she was working for a conservation district as a farm planner when graduate school found her again. The invitation to return to school for a PhD program was too good to pass up. Caitlin was not a farm kid, and before going to college, she had no idea that agriculture was a field of study. But it was her work with several outstanding land-grant extension faculty that inspired her to be a public scientist in the field of agriculture, and encouragement from a mentor that set her on a path to extension work. Please help me welcome Dr. Caitlin Younquist.
I've been asked to come and kind of get us started here with a little bit of an introduction to soil. It's a topic that I find very interesting and very important, and hopefully we can get you inspired today, and you're going to hear from some great speakers. So we're just going to get started a little bit with an introduction to soil. So I find definitions helpful, and I think when we're talking about something like soil that we stand on every day, it's helpful to have a good working definition. And one way to think about it is it's really basically a lot of really old rocks on the surface of the earth that we owe our survival to, right? And another way to think about it is that it's a living system, and it's that living system of plants, insects, and microorganisms that we are especially concerned about when it comes to soil health. Another way to think about this is that it's those very old rocks that sort of are inherent characteristics of the soil. These are the things that we cannot change, or they change on the scale of thousands or millions of years. We really don't have much control over those characteristics. And it's the dynamic characteristics that we can change within seasons or years that we have a lot of influence over as land managers. So as land managers, we're working within the constraints of those inherent characteristics to improve the dynamic characteristics to the best of our ability. So what does it take for this thin crust of old rocks on the surface of the earth to become soil or to become a living system, right? It takes hundreds or thousands or millions of years for these rocks to weather over time, breaking down into smaller and smaller particles, and eventually becoming a living system that includes plants, insects, and microorganisms. And it takes, on the best estimates we have, is about 500 to 1,000 years, or thousands of years rather, for 1 inch of topsoil to develop, just 1 inch. So if you're standing on 6 or 8 or 10 or 12 inches of topsoil, think about the amount of time involved, thousands of years, 500 to thousands of years to develop 1 inch of topsoil. So it's very, very valuable, very precious, and very fragile. So if we think about erosion, and if we think about losing maybe even just 1/8 of an inch of topsoil off of your ranch or off your farm, and if we use 500 years per inch of topsoil, which is actually very ambitious, especially considering this arid climate. It would probably take 2 or 3 or 4 times that long, right? To form 1 inch of topsoil. So if you lose 1/8 of an inch of topsoil and you can recover it 500 inches per year, you're still looking at 2 or 3 generations to recover that 1/8 of an inch of topsoil that you might lose off your farm or ranch. And that's really precious, right? That's really what our life depends on, and what our ranch and our farm depends on. So being really thoughtful about how long it's going to take to recover that little bit of topsoil that might blow away. And we can't really afford to lose our topsoil any more than we can afford really to lose our livestock, right? So thinking about that. And I talked a little bit about inherent characteristics, the things we really can't change, and soil texture is one of the biggest ones to think about. And it's really just the percentage of the sand, silt, and clay in your soil. And if you don't know what that is, I would encourage you to get a hold of your local NRCS office or extension office. They're really good at this, and they can help you figure out what your soil texture is on some of your different fields or in some of your different pastures, and help you figure out what some of the strengths and weaknesses are that are dictated by your soil texture. And it's the sand, silt, and clay that's different sizes. So your clay is your smallest particles, your sand are your largest particle sizes, and it's just an important thing to understand about your soil. Another important thing to understand is your soil type. There are 12 soil orders across the globe, and there are over 15,000 individual soil series or soil types found across the world. Now, depending on the size of your ranch, you might be managing 2 or 3 soil types. You might be managing a few dozen soil types. And so to get a better understanding of the type of soil you're working with will help you be a better manager in terms of understanding some of the strengths and weaknesses of those soils. And soil formation is not random, right? So the soil we stand on was formed over millions of years based on several factors. And an important one is where in the landscape was it? Is it the top of the hill? Is it a river valley? North slope, south slope? All these factors are going to be important when we think about the types of soils that we're working with. And what's the climate? Was it a wet climate, cold, dry, hot climate? Those are all going to affect the soil type as well. And the parent material. So is it a glacial soil? Does it come from volcanic ash? Is it alluvial, meaning it was carried by river floodwaters, or those very fertile river valleys that are used for farming? A lot of those are alluvial soils. So those are all going to influence the type of soil we have. And again, this is something that if you'd like to know more about the type of soil you're managing on your ranch, again, extension, getting a hold of your local extension or local NRCS, and they can help you find those maps and learn more about what you're standing on, what you're working with. And again, like I said, all of these are going to have a big impact on the strengths and weaknesses of the soils that you're dealing with. So this is a soil map of Wyoming. And there's a few patterns here in soil types that I think are worth pointing out in order to better understand our role, particularly as land and soil managers. So the blue area shows the soil types that we would see, that we find in the mountains, typically more precipitation, right? Wetter areas, often dark in color. Much of this area has soils that support the ample grass growth for grazing, right? We have the mountain meadows and the grassy slopes that produce really good grazing land. And it's really no coincidence that these are the kind of soils you really would like to dig up and take back to your garden, right? They're often really beautiful soils. And a lot of that is due to higher precipitation and higher grass growth. And so more precipitation, more grass growth, more roots. The roots help build the soil then supports more grass growth. So it's all connected in there. And you're going to hear a lot more about that as we go through the day. But as you have more precipitation, more grass growth, that grass takes that carbon out of the atmosphere into the soil, supports the microbial growth in the soil, builds more carbon, more organic matter, again, supports more grass growth, and that cycle continues. If you look there in the pink and the orange zone, whoops. Oh no, what happened? There we go. Got a little preview there for you. Okay, this is in the pink and the orange zone here. That's the Bighorn Basin. That's where we grow, as you know, a lot of sugar beets and barley and beans and alfalfa. And very, very dry. A lot of areas high in salts. And again, you can see the orange area is particularly where we have the alluvial soils, the river flood plains, very productive with irrigation, of course. So this is an area that needs a lot of irrigation. We have a lot of salt issues there. And they're lighter in color than most of the mountain soils that are under grass, which is often a good indicator of lower organic matter. And they're highly erodible, particularly under our production systems that rely heavily on tillage and not a lot of bare soil, right? So that's something you'll notice in those areas, and a lot of sort of stabilized sand dunes and, again, salt issues. But highly productive under irrigation. And then we get down here into our Intermountain Basin and more foothills there. Some of the oldest soils in the state. A lot of shales and sandstones and fossil deposits. And you'll notice some of the darker yellow there are river sediments left over during Tertiary and Pleistocene eras. And so we can also expect to see, again, some of these more fertile areas here because of their old river deposits. And this side, we get a little bit more precipitation as you move further east, and so you'll get a little more production there as well. More grass growth, more plant growth, and often more carbon in the soil as a result. As you get over here further east, this is where we get into our upland plains. And notice there's 3 different colors of green there. Again, you'll have this transported material, kind of your alluvial deposits, but the river valleys are very narrow, not as wide here, not as productive here as in this area, right? And then you'll have your steeper terraces, your steep uplands here, your dark green, and then your medium green is your rolling upland hills here. And you can think about as we get into the Black Hills and again into the wheat growing areas there of southeast Wyoming. Again, we have enough precipitation to shift this whole area here from more of a sagebrush steppe over more into grassland soils. And again, we expect to see deeper, more fertile soils in that part of the state. And if you look at this map, you can see the precipitation zones too and how that affects the soil types, right? So again, we have more precipitation here, we have more precipitation in the mountains, right? In these really dry areas here. So it's interesting just to think about, there are a lot of factors that go into, a lot of factors and a lot of time go into soil formation, and understanding the soil you're working with and the strengths and weaknesses of that soil and how to manage it are going to be really important in terms of being a good soil manager. So, I've mentioned grassroots several times here, and I'm sure you'll hear more about that as we go through the day. But the plant roots and the rain that makes those plants grow are largely responsible for creating our healthy, productive, and profitable soils, right? And in this example from grassland soils, there will be about 4 or 5 times as much biomass below ground as there will be above ground, right? And up to half of that is recycled every year. And that recycled means it dies back, sloughs off, recycled, and turns into carbon or organic matter in the soil. And that's how you get these really deep, fertile mollisols. This is the type of soil you'll find in tall grass prairies, right? Because all that grass those grass roots have been recycling over hundreds of thousands of years and building that soil there, and putting that carbon or organic matter back in the soil. And so what's happening is the plants, through the process of photosynthesis, are taking the carbon dioxide out of the air, and they're putting it into biomass, into the above ground and below ground biomass. And that biomass gets recycled and gets moved down deeper into the soil, and that's what makes soil organic matter. And soil organic matter is about 50%, almost 50% carbon, right? It's mostly carbon, has a lot of other good stuff in it too. But really what you're looking at with the work of plant roots is you're taking the carbon out of the air and putting it into the soil and keeping it there where it's useful. If you're familiar with the term carbon sequestration, that's exactly what this is right here. You're taking the carbon out of the air and putting it into the soil where it's useful. And that's supporting the microbial life that Pete's going to talk about here shortly. There's an incredible world down there, and he's going to tell you a little more about that. Here's a picture. I took this actually out of a hayfield out in Marlon. You can actually see it happening. Here's an alfalfa root, and you can see right where that alfalfa root is. See that dark area there, where those roots actually secrete materials that contain carbon out of the roots, feed the microbes, and the microbes are starting to build soil and improve structure and function of that soil right around that root. So if you get out and dig holes and look, you'll see that happening. Here's an interesting little factoid here. There are more soil microorganisms in a teaspoon of healthy soil than there are people on Earth. And you can ask Pete because he's counting, and he can tell you how many there are. And there are more species of bacteria and fungi in a gram of Wyoming soil than there are species of plants in the state. Over more than 2,200. So that's kind of a fun, interesting fact, also. So there's a phenomenal amount of life down there and diversity, and a lot we don't even know yet. We're still learning, but you'll learn a little bit more about it today. But it's really, really important and a fascinating world. Another interesting thing is more than half of our commercially available antibiotics come from soil organisms originally as well. So there's a lot of life down there. So we talked a little bit about inherent and dynamic characteristics and ways to think about soil, and I want to touch a little bit also on our biology, chemistry, and physics. Right? Think back to our high school science classes here. So some of the chemical characteristics of soil, we're pretty good at chemistry. We've been doing soil chemistry for a long time. A lot of that's balancing fertilizer recommendations. We measure our pH levels, our acidity, our salts, nitrogen, phosphorus, and potassium, our macronutrients and our micronutrients, and our carbon in the soil. Those are all things that we can measure in the lab. Those are that's sort of balancing the soil chemistry. We're pretty good at that. We've done that for a long time. We also have our biological factors. So crop condition and disease pressure. We can look at the amount and the type of microorganisms in the soil. There's some really interesting laboratory tests you can do and field tests to look at that. Earthworms, of course, are a big part of it, all the life in the soil. And then we have our physical characteristics of the soil. So erosion, compaction, infiltration, how fast the water moves through the soil, and our structure. So those are all things that we also can look at in soil. You notice carbon is on here twice. I put carbon under the biological side of things only because carbon itself is not alive, but it's the driver for the biological system. So it's a really important part of the biological system of the soil. And we're really good at this. We're really good at measuring, taking our soil test, sending into the lab, measuring the chemistry of the soil. We're really good at figuring out which implement to pull through the soil to break up compaction, or which implement we need to put on the tractor today to get the soil prepped for planting, right? So we're pretty good at the chemical and physical part of the soil. And where we really have a lot more to learn is the biological. And so when you get all three of these overlapping here, when you consider all three of these functions of the soil, that's where we're really talking about soil health and getting everything working together there, all three of those factors. You think about this in terms of livestock, right? So we've got, think about nutritional deficiencies would be maybe like a chemical deficiency. Conformation, we want to have an animal that has good conformation, strong legs and feet, good physical condition, and an animal with a strong immune system and healthy rumen biology and all those things. So again, if you're missing one of those three, right, you're losing money or you have animals that are not very productive. So thinking about having all three of these for your livestock health, for your health, and for your land health. So we talked about soil health, that's what today is all about. What exactly is health? When we talk about soil health, again, I think it's helpful to have definitions. There's a few different ways to think about this. One is thinking about health as the capacity to function, right? So whether we talk about livestock health, human health, land health, high functioning, high capacity to function, right? If you look at the dictionary, as I was working on this, I thought, I wonder what the dictionary says about health, right? Ability to adapt and self-manage in the face of challenges. I think this is another really good definition to think about. So if we have healthy livestock, healthy humans, healthy land, we want to be able to adapt and self-manage in the face of challenges or under pressure when we have stressors, right? Another way to think about that is being resilient. So is our land resilient to things like drought, compaction, erosion, and disease? So is our soil really resilient when it comes to those stressors on the system? And the same could be said for livestock, right? So do we have livestock, do we balance the physical, biological, and chemical factors? And do we have resilient, healthy livestock and resilient, healthy land? So that's well and good, but what do we do to get healthy soil? You'll be learning all about that this morning. Here's one way to think about it. A lot of it comes down to soil organic matter and soil carbon. That's really the driver of the system, right? And again, most of that's carbon, and most of that should be coming from the plant roots through photosynthesis into the soil, right? So if we're looking at increasing our soil organic matter and increasing soil health, we want to get the carbon in the soil and keep it there, right? So that's key. So plant roots are a big part of that, especially when it comes to rangeland, right? Plant roots are huge. If you're managing hayfields or cropland, you're looking at other possible additions would include compost and manure, right? And then we want to keep it there, which means minimize our losses. So tillage is a major loss of soil carbon. Bare soil and erosion, right? Other ways to lose your soil organic matter, your soil carbon. So keeping this carbon in the soil, getting the carbon into the soil and keeping it there are key. And the reason you're going to do that is you're going to feed the bugs, right? Feed the microbes, and people talk more about that. And let the system work the way it was designed to work, right? There's a reason that there's all these feedback loops, there's all the ways that the plants support the soil supports the plants, the microbial life. It's an incredibly complex world there, and you'll learn more about that. But that's a way, sort of a very basic way to start thinking about building your soil health. Get the carbon in the soil and keep it there, feed the microbes, and let the system work the way it was designed to work. So there's your introduction, something to think about. This is my contact information. I'd be happy to visit with you more. I'd love to get out and visit folks on their place. And if you'd like to, I keep a newsletter where I send out resources like this. I'd be happy to have you sign up, and feel free to call or email me anytime. And turn it over to the next group here.